Let us see one example for this lossless join and dependency preserving. Suppose we have one relation teach with this attribute student, course and instructor, and functional dependencies are student, course determines instructor, instructor can determine course. Here key would be student and course. This is the candidate key. Here prime attributes are not deriving any non-prime attributes, so there are no partial functional dependencies here, and non-prime attribute instructor derives course, but this course is prime attribute, so this is not transitive dependency. So this relation R satisfies 2NF and 3NF, but it will not satisfy BCNF because this instructor determines course. This instructor is not key here. Here determinants are student, course and instructor, and key is student course, but this instructor is not the candidate key, so this will not satisfy BCNF. Let us decompose this into BCNF. Possible decompositions are R1 with student and instructor, R2 with student course. Again, second decomposition, R1 with course and instructor, R2 with course and student. Third decomposition, R1 with instructor course, R2 with instructor and student. All three decomposition lose the functional dependency FD1. Student course determines instructor. But from these three decompositions, which one is good decomposition? We already seen we need to make two properties of decomposition during the normalization process. Non-additive or lossless join property, functional dependency preservation property. We are not able to make the functional dependency preservation for any of the above BCNF decompositions, but we must meet the non-additive or lossless join property. Let us check this. First decomposition, R1 with student and instructor, R2 with student and course. To check this decomposition lossless or not, we have to check this FT R1 intersection R2 determines R1 minus R2, or another FT R1 intersection R2 determines R2 minus R1 is in closure of F. If either of these FDs are in closure of F, then we can say that this decomposition is lossless. Let us check what is the intersection of this R1 and R2. Student is the intersection. Student determines what is the R1, student and instructor minus R2. We have to remove this student from here. So R1 minus R2 would be instructor. There is no FT. Student determines instructor in this closure set of attributes in original relation R. Original relation FTs are student course determines instructor, instructor determines course. From these two FTs we cannot derive any other new FD, so this will be the closure set for the F plus also same these two set of FDs. So this student determines instructor is not in this closure. Another one, student determines R2 minus R1 means student course minus student instructor. So again here course student determines course is also not in this closure. So this decomposition is not lossless, means when you join these two tables by using natural join, you will get additional tuples. This table is the result of natural join between these two decomposed relations. But this is the original table. It has only 9 rows. Here we have more number of rows, which is not lossless decomposition. Let us check with second decomposition. R1 with course and instructor, R2 with student and course. R1 intersection R2 would be here. It is course. Course determines R1 course and instructor, R2 student and course, so we have to remove course from this R1, so it would be instructor. Course determines instructor, which is not there in this closure set. And let us check for the second FT. C determines R2 student and course. From this we have to remove this course, so course determines student, which is also not present in this closure. So this decomposition also not lossless. Even if you join these two tables, you will get additional rows. Original table has only 9 rows, but here we have more number of rows. This is also not lossless decomposition. Let's check for the third decomposition. R1 with instructor and course, R2 with instructor and student. Here common attribute is instructor. Instructor determines R1 attributes instructor and course, R2 attributes instructor and student. You have to subtract this R2 from R1, so we have to remove this instructor from the R1, so you will be left with this course. So instructor determines course. See here, the FT instructor determines course is enclosure of F. So this will be the lossless decomposition. So here this R1 will hold this functional dependency. Instructor determines course, but we cannot infer the student course determines instructor, so this dependency will be lost, so which is not dependency preserving. If decomposition is lossless, if you join these two tables, then you will get equal number of rows which are in original relation. Here also we have only 9 rows. This table is equal to this original table. So this third decomposition, R1 with instructor course, R2 with instructor and student, is the desirable decomposition. Instead of checking for this FTs, we can take the R1 intersection R2, which is the instructor, which is the primary key of this relation R1. Here we have FT, instructor determines course, so here this instructor will be the primary key. So if R1 intersection R2 is the key of either of these relations, then simply we can say that the decomposition is lossless.